Well, hello and welcome to today's lecture. We're going to start chapter 4. So what we learned so far, we learned that in statistics, we are dealing with different types of variables. We talked about two different types of variables when it comes to statistical analysis. The first one is discrete. The second one is continuous. So, what's the difference between them? Discrete or continuous. So, discrete variable is a countable variable. Discrete or countable. Give us an example. For example, you can count the number of students sitting in statistics class. For example, the number of students in stats class. You can count them. It's not unlimited. You can actually say, hey, I have 1 student sitting in your class, I have 2 students sitting in your class, I have 3 students, 4 students, 5 students, 100 students sitting in my class. How about continuous? Continuous variables are variables that take on values in between two numbers or over an interval. So for continuous, we cannot count them. There are a lot of them. It's impossible to count each of them. They take on values over an interval. Okay, what do I mean by that? Think about it this way. When we are talking about height, or when we're talking about weight, or when we're talking about volume, it's impossible to count all decimal numbers, all decimal values. It's actually impossible. So what do we say? We say that, hey, for example, the height is between 4.8 to 6.2. Height can take on every possible values over this interval. So this is the general idea. We're going to talk about probability or function related to these variables. Chapter 4 and Chapter 5 are both dedicated to probability distribution for different variables. So another example of a discrete or countable variable is the number of companies in Silicon Valley. Example. The number of companies in Silicon Valley. Let us write down some examples for continuous variable. For example, volume. For example, height. For example, weight. For example, time. And so on. It's impossible to count them. So we're going to say, hey, this is just an example of a continuous variable. So when it comes to different variables, you can assign different functions or different probabilities to those variables. So note that to each variable. So in general, we denote a variable using x. We can assign a function. What is that function? We're interested in probability as a function. P of x is the probability of variable x. So that depends. If you have a discrete variable, you can actually count all of those probabilities. If you have a continuous variable, it's impossible to count all of those probabilities. So what's the difference between the graphs? Note that when we graph probability of variable x for x as a discrete or countable variable, the graph is discontinuous. Of course, when you graph a probability function for a continuous variable like height, like weight, like volume, like time, the probability as a function as a continuous graph. When we graph probability of x for x as a continuous variable, the graph is continuous. Very well. Okay, so now that we talked about the probability as a function, we're going to talk about the properties of this probability function. When we say P of x is probability distribution function for variable x. So in general, suppose you have a random variable. Let x be a random variable. It doesn't matter if it's discrete or it's continuous, just a random variable. P of x is called probability distribution function. If it satisfies these conditions. First of all, probability of any variable must be a decimal number between 0, 1 inclusive. So P of x as a number is a decimal number which is between 0 and 1. So if somebody is saying, hey, the probability is equal to, I don't know, 125%, it's wrong. So P of x equals to 1.25. You say, hey, I know the definition of probability distribution function requires for the probability to be a number between 0 and 1 inclusive. It cannot be greater than 1. So you say that, hey, your probability is wrong. You have to do the calculation one more time. B. So X is a random variable. What's the meaning of that? X can be 0, X can be 1, X can be 2, X can be 3, X can be a number, any number. The number of people living in a house is changing. It's a variable. The probability of the number of people living in a house is a number. Of course, it is between 0 and 1. Is it 1%? Is it 2%? Is it 50%? Is it 60%? Part B says, if you take all of those probabilities, add them all together, it must be 1. Otherwise, it's not going to be a probability distribution function. So the sum of all probabilities must be 1. Mathematically, symbolically, we write sigma sum of all probabilities, P of X, and down here you write X, since your X is changing, must be equal to 1. So that's how we read it, that's how we write it in math. Well, on page 3, we have an example. A table is given to you. Let us read this example, then go over the solution together. In this example, the question says, constructing and graphing a discrete probability distribution. An industrial psychologist administered a personality inventory test for passive-aggressive traits to 150 employees. Each individual was given a score from 1 to 5. So how many people? 150 people. Each were assigned a number between 1 to 5, where 1 is extremely passive and 5 is extremely aggressive. A score of 3 indicated neither trait. The results are shown at the left. So this is your table. Construct a probability distribution for the random variable X, then graph the distribution using a histogram. Very well. Okay, guys. What do we have here? We have a table. On the left-hand side, you have 5 scores, which is your variable X. So scores are changing between 1 to 5. On the right-hand side, you have the frequency, which is the number of employees who are assigned these scores to. So 24 employees got score 1. 33 employees got score 2. 42 employees got score 3. 30 employees got score 4. and 21 employees got score 5. We want to form probability distribution function for this variable, which is our score, and then graph the histogram. So we have score, which is x, which is our random variable. In this case, since you can count them, it's going to be a discrete random variable. Okay. Score 1, 2, 3, 4, and 5, and frequency, or the number of employees, 24, 33, 42 of them, 30 of them, and 21 of them. Our goal is to form probability function for this variable. So we want to construct a probability function for x. So how did we define probability? Probability of an event or a variable is defined as you have a fraction. On the numerator, you have the occurrence of that event or variable. On the denominator, you have the total frequency or the total number of values in your sample space. So, frequency of x divided by the sum of all frequencies. How many x do you have? You have x equals to 1, you have x equals to 2, x equals to 3, x equals to 4, and x equals to 5. You also have the frequency or occurrence of each of those events or values. So you can form the function, probability function, for each of these x values. X is 1. X is 1. The probability of x equals to 1 is equal to frequency of 1. 24 employees got score 1. So the frequency of score 1 is 24. 24 goes on the numerator. On the denominator, how many employees do we have? We have 150 employees. This is your first probability function, and this is the value assigned to that function. If x is equal to 2, probability of getting score 2 is a fraction. On the numerator, you get the frequency, which is 33. On the denominator, how many employees do you have? 150. Next score is 3. The probability that x is equal to 3 is equal to the total number of employees who got score 3 divided by the total number of employees who were surveyed. 42 divided by 150. What if x is 4? When x is 4, the probability that x is 4, or the probability of employees who got score 4 is, on the numerator you have 30. 30 of them got 4 out of 150 of them. And finally, the probability that x is equal to 5, P of 5, is the frequency of employees who got score equal to 5, which is 21 divided by the total number of employees who get surveyed, which is 100. Well, now that we know how to find the probability distribution, we want to write them in nicer format. Okay, 24 divided by 150 is equal to 0.16. 33 divided by 150 is 0.22. 42 divided by 150 is 0.28. Then 30 divided by 150 is 0.20. And finally, you have 0.14. Now let's graph this to see how we can visualize this variable using its probability function. To form or construct the probability histogram, on the horizontal axis, you have to list all of the values for your x. So here you have your x. How many x's do you have? You have 1, 2, 3, 4, 5. X can be 1, x can be 2, x can be 3, x can be 4, x can be 5. Okay. Remember that when you form the histogram on the vertical axis, you usually use the frequency. Then you use relative frequency. Now you're going to use the probability distribution function. So on the vertical axis, you have your P of X. So you have 16%, 22%, 28%, 20%, and 14%. So let us go with this one, 0.30. Just a scale. Makes it easier for us to graph this probability distribution histogram. When x is 1, its probability is 16%. Remember that we are forming a histogram. All bars must be attached to each other. So 16%. This is my first bar, and I stop at 16%. My second bar, so let me just move this a little bit here. I want them to have no gaps. Okay, perfect. 2, the probability of x being 2 is 22%. So I'm going to stop at 22%. Suppose 22% is here. 3, probability x is equal to 3 is 28%. Okay, let's just shift this a little bit here. 28%, so it's getting closer to 30%. Probability x equals to 4. Let me write this right here. 5. Just want to scale them better. X equals to 4. The probability is equal to 20%. So this is your next bar. 20%. And finally, x equals to 5. The probability is equal to 14%, which is going to be here. This is how we use probability function to visualize the distribution of each of these scores. Let us move on to the next example. On page 4. you have an example and somebody gives you a probability distribution related to some variables and they ask you, hey, this is what I have. As a statistician, do you think this is a correct probability distribution? So suppose you have this table. Verify the following is a probability distribution or not. So you have the following table. This table is days of rain, which is your variable, x, and they found some probabilities for those variables, p of x, as follows. 0 days of rain, the probability they found is 0.216. 1 day of rain, the probability they found is 0.432. 2 days of rain, the probability that they found is 0.288. 3 days of rain, they found probability to be 0.064. Okay, you are the statistician, you want to check to see if this is a valid probability distribution or not. Remember the properties for probability distribution function. Each probability must be a decimal number between 0 and 1 inclusive. And if you add all of those probabilities, it must be added up to 1. Let's check each of them. So we need to check the following. First of all, p of x must be between 0 and 1. How many x do you have? You have 1, 2, 3, 4 x values. If x is equal to 0, p of 0 is equal to 0.216. Is this between 0 and 1? Of course. The second variable is 1 day of rain, and the chance, the probability is 43%. So p of 1 is 0.0432. Is this between 0 and 1? Of course. This is a decimal number between 0 and 1. P of 2, which is 0.288. How about this probability? Is this a number between 0 and 1? As you can see, we have 0.28, roughly 29, which is of course a number between 0 and 1. And finally, when x is 3, your probability is 0.064. So p of 3, 0.064. This is very obvious. This is a very small number, very close to 0. So the first condition is met for each of these numbers. B, now if you add all of the probabilities, it must be equal to 1. Otherwise, you say that, hey, your calculation is wrong. What information that you provided is wrong. You have to do the calculation again. So p of 0 plus p of x equals to 1 plus p of x equals to 2 plus p of x equals to 3 must be 1. So let us add them all together, see if we get 1 or not. The first probability, 0.216 plus 0.432 plus 0.288 plus 0.064. If you add all of these numbers together, it is equal to 1. So the second condition is also met, and as a statistician, you verify that this is actually a probability distribution function for this variable. So one important note for you is probability distribution function for a variable cannot be a negative value. P of x is never negative. So if somebody say, hey, the probability of variable, for example, x equals to 1, I got negative 20%. You stop and you say, hey, it's not possible for a probability distribution function to be a negative value. This is wrong. So P of x is always a number between 0 up to 1 inclusive. Never greater than 1, never less than 0. Now I expect you to ask, okay, so you're saying that instead of using the frequency for each of the values in the collection, I can use the probability distribution function. Okay, now how can I find the mean, variance, standard deviation of the data collection that I have? Page 5. So now we are using P of x to get information about our data. We can use Px to find the mean of the collection. To find the average or the center or mean of the collection, the formula is mu equals to the sum of the product of each x value by its probability. So what you do, you find all of x values, find all of their probabilities, multiply them, add each of them together to find the mean. So you gotta write it this way. U is equal to 0 times P of 0. 1 times P of 1 plus 2 times P of 2 plus the rest of it. That's how you find the mean of the collection using probability distribution function. Okay, perfect. Example. The probability distribution for the personality inventory test for passive-aggressive traits discussed in example 2 is shown at the left. Find the mean score. Very well, let's go over this example. Let me erase this part of the board. So our goal in this example is to find the center, or you might say a typical score so as you know, you have to multiply each x by its probability. So your x, your P of x, and I'm going to construct a new column which shows the multiplication between x and px. So my first x is 1, its probability is 0.16. So x times p of x is 1 times its probability, which is 0.16. The second x, the second score is 2. The probability is 0.22. So x times p of x, 2 times 0.22 is 0.40. Next x is equal to 3. Its probability is 0.28. X times p of x, 3 times 0.28 is 0.84. And finally, you have 4 and then 5. For 4, the probability is 0.20. X times its p of x, 4 times its probability is equal to 0.80. And finally, you have 5. The probability for 5 is 0.14. If you multiply 5 by 0.14, what do you get? 70%. So we found these values. Now we're going to add them all. Now, add them all. What do you have? You have 0.16 plus 0.44 plus 0.84 plus 0.80 plus 0.7. If you add these together, the sum is equal to 2.94, which is a typical score for the center of the collection of the data that you have. Center or typical score. Very good. So what about standard deviation? So we calculated the mean or typical value, but to understand the range or any spread in your collection, what do we need? We need our standard deviation. So we're going to use a different formula to find standard deviation when p of x or the probability distribution function is given to us. Let me erase this line. And the standard deviation is sigma equals to the square root of. Now you are taking each x minus mu, you square it, and you multiply it by p of x. Standard deviation for sigma is equal to square root of, so this is the sum. You find mu, mean, typical value, x minus each mean, you square that value, multiply by p of x, the probability for that specific x. You calculate each of them, add them all together, you have your number, then you take square root. So if you want to write sigma in detail, you have sigma equals to square root of 0 minus mu squared p of 0 plus 1 minus mu squared times p of 1 plus 2 minus mu squared times p of 2 plus the rest. Very well. Let's get back to our previous example. We're going to try to find standard deviation for those scores that we have. Okay, let me write this here for you. And note that the mean that we found is 2.94. We already have 2.94. Let me erase this one as well. So I have x, I have p of x. I already found my mu. My mu was 2.94. So this is our previous example. We're going to find the standard deviation for it. The first x was 1, the probability 0.16. The second x was 2, the probability is 0.22. The third x was 3, 0.28. The fourth one, 4, 0.20. And finally, we had 5, which was 14.14. X, px, those are given to you. Now, you need to find x minus mean. So in this column, I'm going to calculate x minus mean, and note that in previous example, we calculated the center or typical value, which was 2.94. So x is 1 minus 2.94. X is 2 minus 2.94. Mu is fixed. 2.94 that we found before, but x values are changing. 3 minus 2.94. 4 minus 2.94. And finally, 5 minus 2.94. We need to calculate each of these. After we calculate each of these numbers, we have to raise the number to the second power, which is x minus mu to the second. Okay, so let us write these numbers here. Negative 1.94. Now negative 1.94 raised to the second power, which is 3.76. 36. The second subtraction gives you negative 0.94. Now negative 0.94 raised to the second power. The second row is 0.8836. Now we do the subtraction here, 0.06 and 0.006 raised to the second power, which is give you 0.0036. Now 4 minus 2.94, which is equal to 1.1236. Now you raise this number to the second power, which is equal to, that's a huge number, 0.2247 and 20. And finally 5 minus 2.94, which is equal to 2.06. Now you raise 2.06 to the second power, which gives you 0.594104. You just calculated this quantity, x minus mu squared. Now you have to multiply each of these numbers by their probabilities. So we are forming a new column, which is x minus 2.94 to the second power times p of x. You take each of these numbers, you multiply by their probabilities. So here you have 3.7636 times its probability, which is 0.16. This is equal to, okay, let me see, I made a mistake here. So this is 0.0, this is 1.1236. Please correct this. This is 4.0. It's after multiplying by its probability. This is 4.2436. Okay, perfect. So now you have 0.602176. Then you multiply this number, 0.8836, by its probability, which is 22%, 0.22, and you get 0.194392. Next number, 0.0036 times its probability, which is 0.28. It's equal to 0.001008. And next number, this is 0.1236 times the probability, which is 20%, 0.20. It gives you 0.2247 and 20. And finally, the last number is 4.2436 times its probability, which is 14%, 0.14. This is equal to, let's see, 0.59, 41, 04. Next step is to add them all together, then take square root. So the square root of the sum, this is equal to your standard deviation. So you have square root of, if you add these together, you get 1.6164. And you take square root, which is equal to 1.3. This is your standard deviation. So we talked about the mean and standard deviation for a discrete variable. Note that a continuous variable has a different probability distribution function. We're going to talk about it next week. The last topic is expected value. So if you have a discrete random variable, the mean of random variable represents what you expect to have happen over 1,000 of traits. It's also called the expected value. So definition, the expected value of a discrete random variable is equal to the mean of the random variable. Instead of having mu, we're going to use E of X. So when you use E of X, it means that you have expected value. Although probabilities can never be negative, the expected value of a random variable can be negative. So that's the main difference between expected value and the mean. You might end up with a negative expected value. Let us take a look at one example here. A raffle, 1,500 tickets are sold at $2 each for 4 prizes of $500, $250, $150, and $75. So you buy one ticket. What is the expected value of your gain? Well, first of all, to find the gain for each prize, you have to subtract the price of the ticket that you purchased from the prize. That makes sense. So you have 500, you have 250, you have 150, and you have $75. So you have to subtract 2. You pay $2 to purchase the ticket, and 500 minus 2 is going to be 498. So the gain, 498. 250 minus $2, it gives you 248, okay? The second X. Then You have 150 minus $2, which is $148. Then you have 75, which is 75 minus 2 gives you $73. And finally, you have loss. That makes sense. You might not win any prize. So you're going to add minus 2 as well. So none of these cases might happen for you. You might lose the ticket and your loss is going to be negative $2. You lost $2. So this is negative 2 here. Well, now we have to calculate the probability for each case. So what are the chances that you win and gain $498? It's 1 out of how many tickets? 1,500 tickets. The second one, also the same probability. Your chance is just 1 because you just purchased 1 ticket. Then 1 out of 1,500, 1 out of 1,500. And finally, what are the chances that you lose that $2? 1496 divided by 1,500. So we have our probability distribution function. The expected value is going to be the product of each x by its probability, and finally the sum. If you add all of these together, the outcome is negative $1.35. So because the expected value is negative, you can expect to lose an average of 1.35 for each ticket you buy.